Unit 2, Day 4, we are going to be talking about factoring completely. When we do factoring completely, it means that you will probably have to factor more than once. Quite often, that's going to be 2 steps of factoring, but occasionally that might be 3 or more steps. When we go through and we do our factoring completely, the first thing that we always want to look for is a GCF. So GCF can stand for greatest common factor, which is what we usually think of in math, but it also is kind of nice to think of it as gotta check first, GCF. So my step 1 every single time is going to be for looking for a GCF. Step 2, we're going to look to see if we have a dots problem. And remember, with dots, it has to be a binomial with what you're working with. In addition, it also must be a difference, so it must have a minus sign, and both of the terms must be perfect squares. The third kind of factoring I'm going to look for is trinomial factoring. That means that we know we're going to have a trinomial with 3 terms, and we have to decide if it's AM, add to this, multiply to this, or split the middle. And the way that we tell the difference is if our A term is equal to 1, it's add multiply. If our A term is greater than 1, it's a split the middle problem. We also are going to be looking for factor by grouping, and factor by grouping, notice it says has a minimum of 4 terms. When you feel like you're completely done with your factoring process, the last thing that you have to always remember to do is to go back and make sure that none of your factors can be factored again. So when we take a look at question number 1, on question number 1, I'm going to go through my steps of factoring, and the first thing I'm going to look for is a GCF. So when I go through and I notice the GCF in this case of 2, that 2 is going to come out in front of a set of parentheses. And my steps are going to be to go back to the original problem and divide each and every term by 2. When I get to that point, again, I'm always checking to see if what's in my parentheses can be factored further. And what I notice is that that is a trinomial in the parentheses. And I will say that because there's a 1 in front of the x squared, this will be an add multiply type of question. So over here, I'm doing trinomial factoring, and I'm doing the add multiply kind, which means the 2 that was the GCF is going to continue to carry along, and the trinomial will be factored into 2 sets of parentheses. I want factors of 2, which I know are going to be 1 and 2. It makes sense to use those numbers because I need them to add to 3, which they do. So plus 2 plus 1. And this is my factored completely answer for this question. When we go on to the next page, we are going to skip question number 2, but we are going to go to question 3. In question 3, remember, if we talk about our steps of factoring, I'm going to jot those down here as a reminder for you. We look for GCF first, dot second. Trinomial is our third kind that we look for. And remember, it could be add multiply or split the middle. And then, of course, we do look for grouping as our fourth kind of factoring. So when I'm looking at question 3, first thing I want to check for is GCF. So the question is there a GCF? And when I look at my 2 terms of x squared and 16, I can see that there is nothing that those 2 share. So this is not going to be a GCF type of question. Then I move on to step 2 and I say, is this a dots question? Well, let's take a look at what we're looking for. We're looking for in a dots question that it has a minus between the 2 terms, a difference, which it does. The exponent must be even. So that 4 that you see on x to the 4th is even. So x to the 4th is a perfect square. The 16, the number that you see in the question, is a perfect square. The square root of 16 is 4. That means that I'm going to be doing dots factoring on this one. So when I go in and I do dots factoring, I have x squared and x squared, because remember this is to the 4th, so I'm going to divide it by 2 and split it up. The 16 is 4 and 4. 4 times 4 gives you 16. To get a negative 16, I need 1 positive and 1 negative. Remember, when you think you are done, you always want to go back and you want to look at your sets of parentheses, because in your parentheses, it is quite possible that you will have something there that can be factored again. For instance, in this case, I can factor the second parenthesis again by using dots again just on that. This x plus 4 that we have here, this is x squared plus 4, I'm sorry, this is just going to carry along. It is not factorable because it's not a difference, so it's not a dots problem, although some kids will tell me that they think it is. And then I'm going to go on and just factor this x squared minus 4. So when I do that, I have x plus 2 and x minus 2. At this point, I want to go back and evaluate if my parentheses can be factored further. This one cannot. It is not dots. This is an x to the first. It's not dots. This is an x to the first. It's not dots. So that is my final answer. X to the fourth minus 16, our original problem, factors into x squared plus 4, x plus 2 times x minus 2. I'm going to skip question 5, and I'm going to go on to question No, I take that back. I'm skipping 4 and I'm going on to question 5. So on question 5, I can see that there are now 3 terms. So now that I have 3 terms, I do know that there will not be a dots question here, because that requires that you have 2 terms and we have 3. I'm going to start with GCF, and when I take a look at this GCF that's here, I can see that all 3 terms can have a 7 taken out of them. So I'm going to factor out a 7, and I'll be left with 2x squared plus x, or just x if you want, or you can put the 1x in there if you want to. Sometimes that's helpful. And then I see that what I have in my parentheses can be factored further. You may not look at that initially as thinking that you can factor further, but please remember, this is a trinomial. It has a leading coefficient of 2, and it's not a GCF, so this is going to be a split the middle question. My numbers multiply to 6, and they have to add or subtract to the 1 that's right here, so these are going to be the numbers that I pick. When I'm looking at the signs, the negative on the 3 tells me that my signs will be different. The plus in front of the middle term tells me what my bigger number is going to get. So this is going to be a positive 3 and a negative 2. I'm splitting this middle. So the 7 stays out front. The 2x squared carries along. Instead of writing 1x as 1x, I'm going to write 1x as plus 3x minus 2x. The minus 3 that we have on the end comes along. And I'll continue this problem over here. I'm going to do 7. 2x squared plus 3x minus 2x minus 3. I'm going to do the grouping. When I do the grouping, I group together these 2 terms, and then I'm going to group together these 2 terms, and I'm going to factor from there. So the 7 carries along. Out of the first 2 terms, I can take out an x and be left with a 2x plus 3. Out of the second 2 terms, I'm going to take out a negative 1 and be left with 2x plus 3. The 7 is going to carry along again, and now I look at my 2 terms and I say, what do these 2 terms have in common? They both have a 2x plus 3, so I'm going to take that out. What's left over when I take that out is the x that's here and the negative 1 that's here, x minus 1. Remember, your very last step should be to look at your parentheses and see if they can be factored further. So when I look at this parenthesis, it cannot be factored. When I look at this parenthesis, it cannot be factored. So my final answer for this factoring completely question is 7 parentheses 2x plus 3 parentheses x minus 1. The next question I'd like to look at is question number 9. And in question 9, we're looking at this one because the exponents are higher degree here. There is not a GCF. There's nothing that goes into 81 and 16. And the first term has an x to the 4th in it, and the second term has the y to the 4th in it. So they don't even share a common variable. So there is no GCF. However, when I look at this question and I notice that it is 2 terms with a minus sign between them, that's a really big hint to me that this is going to be a dots question. So when I do dots, I make 2 sets of parentheses, and inside the parentheses, this 81x to the 4th is going to be 9x squared times 9x squared. The square root of 81 is 9. The square root of x to the fourth is x to the second. And then when I square root this, I get 4y squared and 4y squared. And I'm going to get 1 plus and 1 minus, because every time you factor dots, you factor with 1 plus and 1 minus. When I get to this point, I look at my parentheses and I say, can anything be factored further? One of the things that I notice is that this is trying to act like a dots problem, but it is not dots because of the plus sign, so that's going to stay exactly like it is. But when you look at the second set of parentheses, this one really is dots. Both of your terms are perfect squares, and it does have a difference. So that much is going to be factored into 3x minus 2y and 3x plus 2y. And this, another dots problem, dots upon dots, and this is my final answer for factoring completely on that problem. And then the last one that I'd like to do with you today is question number 10. And in question number 10, when you work on this, you will notice that there are 4 terms there. 4 terms is going to either be greatest common factor, but when I look, all 4 terms don't have a greatest common factor, or it's going to be factor by grouping. So because it's not GCF, I'm going to do factor by grouping on this one. When I do the factor by grouping, I'm going to group these 2 terms together, factor out an A, and be left with c squared minus 25. When I group the second 2 terms together, I'm going to factor out a b, a positive b, and be left with c squared minus 25. And when I do factor by grouping, once I've done 2 mini GCFs, now I look at the 2 complete terms that I have here. Both of them have a c squared minus 25. So I'm going to factor that out, and what I'll be left with is an a plus b. At this point, I look to see if anything in my parentheses can be factored further, and what I notice is that this is a dots problem. So that is going to split up into c plus 5 and c minus 5. The other parenthesis, a plus b, is just going to carry along. So if I go back and regroup for a second on this problem, I did grouping here. I'll just put GRP for grouping, and then in this one I did dots. So you can see you complete one of the kinds of factoring completely before you go ahead and start looking to see if you can do more factoring after that. So you only focus on one kind of factoring at a time when you're working on these questions. Just as a review, because this is going to be extremely helpful to you, your first step is always looking for a greatest common factor. Your second step is going to be dots. It must be 2 terms. Your third step, trinomial, it must be 3 terms. It's either an add, multiply, or a split the middle question. And then your fourth kind of factoring, which a lot of times will have 4 terms, is going to be a grouping question. So these are your 4 steps that you need to work your way through. GCF, got to check first.